Chemical vapor sensors, or electronic noses, are a promising technology that can detect odors just like a human nose. Nate Lewis has published more than a dozen articles about vapor sensors in ACS journals and has made many contributions to this field. He and his research team are currently at work on an affordable, easy-to-carry chemical vapor detection system. Just imagine an iPhone with an eNose attachment that can detect disease on a patient's breath or identify bombs or toxins in public spaces. Caltech grad student Heather McCaig gave us a behind-the-scenes look at Lewis's lab to show us how electronic noses work and how they might help improve people's lives in the future.
In this lab, we work with chemical vapor sensors, which are simply a replacement for the canine or human nose. So many years ago, miners used to use canaries in mine shafts to detect harmful vapors. You can think of one application of the electronic nose to be replacing these canaries in terms of environmental monitoring. To test our sensors, we generate vapors using a bubbler system, which simply bubbles air through a liquid of our choice. In this case, it's butyl alcohol. And so we have a stream of air going down into this liquid, making bubbles. And these bubbles come up with a saturated vapor of this butanol. From there, the saturated vapor goes out and is diluted to the desired concentration, which is then fed to our sensor chamber. So our sensors have a chance to sniff this vapor and respond. The sensors in our electronic nose give us raw data. So what we need to do is take this raw data and look at the fingerprints that this raw data gives us for each chemical vapor. And from these fingerprints, we need to do a little bit more processing to really understand what's going on. We can plot all of that data on 3 dimensions, and this enables us to see that one chemical the array will sniff turns out to be down in this quadrant, another chemical turns out to be in this quadrant. One day, what we want is to have electronic noses integrated into smartphone-sized devices. Say a doctor could carry around their smartphone, have patients breathe into a little attachment and be able to tell that they have a communicable disease like tuberculosis immediately. You would not need to send samples off to a laboratory. You could immediately start treatment. And this would have a huge impact in people's lives.